So a very typical formula, a very typical situation that you may see with this kind of problem is that you're asked to find the sine of 2x, cosine of 2x, tangent of 2x, given that cotangent of x equals 3 halves, and that x lies between pi and 3 pi over 2. So it means that that the angle is in the third quadrant. One of the good things about the double angle identities, I don't have to pay attention or be concerned about what quadrant the original angle was in so much, or even be concerned about where the doubling of that would put me. Whereas with half angle identities, I'm going to pay really particular attention to that. However, one of the things, if you looked at those formulas, or if you continue to look at the formulas that are on your guided notes, most of these formulas, especially for the sine of 2x and cosine of 2x, involve me knowing the sine of x and the cosine of x, and cotangent x is not going to be necessarily all that helpful to me. So I am going to draw a picture of the situation, show that x is between pi and 3 pi over 2, produce a situation where the cotangent would be 3 halves, and that would mean that I would have basically, kind of an x movement of -3 for every downward movement of 2 for the y's. Sorry, -2 movement. And I can come up with what the radius of rotation is by using the Pythagorean theorem. So these are things that we've done before, so I'm not showing them in as much detail as I had in the past, but you should know how to get to these. And so as I look at this, I can say that the sine of x is -2 over the square root of 13, that the cosine of x is -3 over the square root of 13. Now I can use the identities. The sine of 2x is 2 times the sine of x times the cosine of x. And if I substitute, now again, notice I'm substituting for the entire trig function. X is not -2 over the square root of 13. It's the sine of x is -2 over the square root of 13. Sometimes, again, students have issues substituting these incorrectly, and they end up doing more work that's necessary, or in some cases where exact solutions are required or requested, or you're told that no calculator should be used, and students want to start using a calculator because of what they actually set up. So as I work this out, I would get 12 over 13 when I multiply that all through. So that would be the sine of 2x. The cosine of 2x, there's 3 different formulas for the cosine of 2x. I tend to use this one most often. You can use any of them that you want, and then any of them will give you the right answer. But I use this one here. Cosine squared x minus sine squared x, which means I'm going to take the cosine of x and square it, which in this case is -3 over the square root of 13. Square that. I'm going to subtract away the sine of x, which would be squared. So I would get 9/13 minus 4/13, and I would get 5 over 13. And lastly, I could either use the identity that I have for the tangent of 2x, the formula that I have in that box, or I could just use the fact that the tangent of 2x should equal the sine of 2x over the cosine of 2x. And that would give me 12/13 over 5/13, which would be 12 over 5. So there's other ways of handling that based on other identities that we can make use of. So this will let me also know that, whatever 2x is, if I want to find 2x, I probably could as well, but that would require me to have an angle that either in radians or degrees would not be, exact. It would be an irrational answer, and I'd have to round it somewhere. But I would know that, that 2x would end up in the first quadrant, because I can see that the sine, cosine, and tangent are all positive, and that's the only place that would happen.